Okay. Good morning, all. So, we'll look into this subject Big Data Analytics, Module 1 Introduction to Big Data Analytics. So, first of all, we'll see what is the need of big data, what is big data, and what is the classification behind this. As the name indicates, the rise in the technology has given the scope for the growth of the data. And earlier the data was in the size of megabytes, but now it is in the size of petabytes, and this is used for basically processing, analysis, discovering new facts and generating the knowledge. So we can look at this graph which shows us the evolution of big data and their characteristics. So data size varied from megabytes to gigabytes, gigabyte to terabytes and petabytes. So we can see also the movement. So when the data was in megabytes, the application was restricted to EDP, IS, and as the data rose up to gigabytes, it could be made of use of it in enterprise resource planning. Then we moved on to web data, and slowly we are into big data. So huge data is collected. So initially the different types and formats allowed were earlier we had only simple and structured data types. Then as applications increased, we moved on from complex relational databases, then tables, SQL structures and data types, and finally moved up to complex and unstructured data types. So definitely huge collection of data gives rise to new tools for processing and analysis of a large volume of data. So an example of a structured data storage and querying in RDBMS is shown above. So volume, velocity and variety, 3 V's were earlier used. Okay. And when integrated with IoT sensors and machine data, the veracity of data also came in. That is the next feature. So the earlier feature was only volume, velocity and variety. So we have the 4th V now, which gave rise to veracity. So an example of unstructured database is NoSQL. So some of the key terms that we are going to use over ahead is applications, application program interface, data models, repository, data store, distributed data store, database, and so on. So application, no doubt we are very much aware about it. So this is nothing but a software collection or software components. So softwares are basically used for acquiring, storing, visualizing and analyzing the data. Next we have APIs. This refers to a software component which enables a user to access an application, service or software that runs on a local or remote computing platform. An API initiates running of the applications on receiving the messages from the end user. So data model refers to a map or schema. So this represents the inherent property of the data, and the map shows the groupings of data elements like records, tables and their association. Next is repository. This refers to the collection of data. So data seeking program relies on the data repository for reporting. So examples of repositories are databases, flat files and spreadsheet. So store refers to a repository of a set of objects. Data store is a concept for actually the repository, like a database, a relational database, flat files, spreadsheets, mail servers, web servers and so on. So the objects in data store model are instances of the classes which the database schemes define. So distributed data refers to data store distributed over multiple nodes. So one such example is Apache Cassandra. Next is database. This refers to grouping of tables for the collection of data. So a table ensures a systematic way for accessing, updating and managing the data. A database is a repository for querying the required information, and why we query is for analytics, processes, intelligence and knowledge discovery. So table means it is a presentation which consists of row and fields. So the value of these fields can be either number, a date, or hyperlink, image, object or text. So flat files means it's a file in which data cannot be picked from in between, and it should be read from the beginning. So flat file database refers to database in which each record is in a separate row unrelated to each other. CSV, as the name indicates, is comma separated values. And when I say name value pair, for example, if I want to have a name value pair is a date, then the number of chocolates sold. So this is what is the name and value. Key value pair represents a field, or it refers to a construct used in which a field is the key, and this pairs with the corresponding values after the key. So consider this record. So date is the primary key. Next is hash key value pair. This refers to the construct in which a hash function computes a key for indexing and search and distributing the entries. Then spreadsheet is an Excel sheet. Next we have stream analytics. This refers to a method of computing continuously, even when the events are, or even when the events takes place, data flows through the system. Database maintenance refers to a set of tasks which basically improves the database, and this uses functions for improving the performance, such as planning and optimization. Now let's understand what is big data and what are the characteristics, types and classification. Data actually is nothing but information. So definition of the data is, it is a large scale integration and presence of data on the servers. So web is a part of the internet that stores web data in the form of documents. So data present on the web servers could be in the form of text, images or videos. So client interacts with the web, client can access the data responses from the server. Then internet applications includes websites, web services, web portals, online business applications, email, chats, tweets and social network. So these are the examples: Wikipedia, Google Maps, so on. So coming to the classification of data, basically they are classified as structured, semi-structured, multi-structured and unstructured data. Still we are very much bothered about structured data and unstructured data. So structured data, as the name indicates, conforms and associates with the schemas and models. So data structures or structured data are found in tables, that is rows and columns, and nearly around 15 to 20% of data are in structured form. So unstructured data do not associate with any models, so they produce continuously increasing volume of data, both unstructured and structured data. So they generate data in three forms, namely structured, semi-structured and unstructured. So structured data enables insertion operation, deletion, updation and so on. It also allows for indexing, scalability, transactions, encryption and decryption. So an example of semi-structured data is nothing but XML and JSON. So we'll be discussing about this much well ahead. So any semi-structured data contains tags or other markers which separate semantic elements, and they also enforce hierarchies. So semi-structured form of data does not associate with formal models. Next is multi-structured data. So multi-structured data refers to the data consisting of many formats, that is namely structured, semi-structured or unstructured. So multi-structured has many formats. They are found in non-transactional systems like streaming data, data from multiple sensors, data at any websites or enterprise servers. So large-scale integrated systems are thus required to aggregate the data and use them efficiently. So semi-structured data has a greater presence compared to structured. So an example of multi-structured data is given below. So structured component of data and unstructured component of data and multi-structured component of data. The examples of multi-structured data is structured component, unstructured component, and multi-structured. When I say multi-structured, the voluminous data matches comes into picture. And he has narrated that with an example of a chessboard. So an unstructured data does not possess data features like tables or database. So unstructured data are found in files like text files, CSV files. Okay. So data may have internal structures such as emails. The data that do not reveal relationships, hierarchy and relationships, or object-oriented features such as extendability. So some of the examples of unstructured data is given below, like mobile data, website content data, social media data, text and documents, personal documents, text internal organizations, etc. So coming to the definition of big data, it's a high volume, high velocity, high variety information that requires forms of processing for decision making, insight discovery and process optimization. Industry analysts describes 3 V's, that is volume, variety and velocity, as the key management challenges. So as per Wikipedia, it is a collection of data sets so large or complex that traditional data processing applications are inadequate. So big data refers to data sets whose size is beyond the ability of typical database software tool to capture. So as I told you, fourth feature added is veracity. This is an important characteristic to take into account the quality of data captured, which can vary greatly, affecting the accuracy. So what are the different big data types available? So we get big data associated with social networks and web data like Facebook, Twitters, and transaction processing. Then customer master data like facial recognition, date of birth, marriage, anniversary, etc. Then machine generated data and human generated data. So here are some examples of machine generated data. When I say machine generated data, it could be the data that are generated from computer systems or from fixed sensors and mobile sensors. Okay, so next we're going to speak about big data classification.